So you can see my completed tapering sled. Decided to get a little bit fancy and I just cut a groove really quickly on my sled so that way I know my stop isn't going anywhere at all. I scribed pencil lines all along the face of my lamination so that way I know when they're fully tapered and I'm not accidentally leaving a flat. And I also have my jig oriented in the correct direction so that the grain orientation is pointing upwards as it enters the planer. So should be pretty straightforward. I've made this jig wide enough for me to potentially do 3 laminations at once. I'm going to start off with just 2 just in case something goes wrong, but I think it should be pretty straightforward. And again, I'm just going to keep planing until these pencil marks entirely disappear. And then I don't have anything really fixing my stop in place. It's just pressure fit at the moment. But if I do, I just really want to make sure I'm not risking exposing any metal to the planer teeth. Okay, so I got a good learning experience from that tapering jig. You can see this taper came out really nicely. It goes from 3/16 to a little less than a 16th. So taper came out exactly how I wanted it. But initially when I was feeding the sled through, I wasn't thinking that clearly and I was feeding it through like it was a normal standard like 3/4 thickness solid board. So I was turning a half turn every single time, which turned out to be way too aggressive and it damaged this piece. So once I noticed that I had damaged this piece, I realized there's no point in taking off that much material at a time, and I switched to just doing an 1/8 turn at a time. Because I have a DeWalt benchtop planer, it has rubber rollers instead of those steel rollers, so I can take as small as a cut as I want on that planer and still have quite a lot of control without marring the surface of the wood. The school shop also has some of these rubber roller DeWalt planers, but if you are using a standard planer in the shop, you will have to turn at least a 1/4 turn each time. But most likely you probably won't be going quite as thin as I did. I went to below a 1/16 of an inch on one end and pretty happy with how it came out. So you can see it's much bendier up here, much stiffer and thicker towards the base. And then because I cut the edge off of a flat sawn piece of wood, I have nice 1/4 sawn grain along the face. I do have to deal with the fact that this is not grade A lumber like most veneer is. This is more standard quality lumber. So it's going to have some cracks, it's going to have some knots that I have to work with, changes in grain direction. And then it will also have been kiln dried, so the lignin will be crystallized and it won't be nearly as flexible as veneer, which has been kept at a nice humidity its entire life. But this is a great way to really customize the appearance of your lamination. One more thing that I didn't actually address was why I'm tapering these laminates to begin with. Why am I not just bending a consistent thickness lamination and then carving into it afterwards? And the main reason for that is because when I expose those glue lines, particularly at a very acute angle, the glue lines are going to take up that much more surface area than when I'm cutting a lamination at a 90-degree angle or tangent to the curve. So especially if you've used epoxy, which has really prominent glue lines, as you carve through the lamination, the glue line is going to become a very graphic part of the piece. And that can be something you work with. You could potentially dye the epoxy of your laminations and carve through it to really highlight the lamination process. But if you want a nice tapered lamination and you don't want the appearance of those glue lines, then you'll have to taper each individual laminate. So here's a couple examples of what happens when, rather than tapering your individual laminations, instead you bend a consistent thickness lamination and then you carve through those laminates. So you can see, especially right here where I carved through using an angle grinder, you can see all those glue lines being exposed. And it can be a bit difficult to keep them a consistent, nice shape that flows with your piece. And then this one is a bit of an exaggeration because it was a failed glue up. You can see how heavy those epoxy lines are. But you can see one side here has been treated with a 45-degree chamfer. Another side here has been treated with the radius of a blade. So using table saw as basically a giant router table. But in both cases, even though I'm only exposing the glue lines at 45 degrees, as opposed to like 5 or 15 or 30, which could be more typical with a carving, they still become a very prominent part of the component. So I can choose to incorporate these glue lines, or I can choose to use a glue that has less prominent glue lines and hope for the best, like this one.